Hello again and welcome to this module on how do planes fly. I'm going to break down exactly how planes are able to leave the ground, stay in the air, and be controlled safely by pilots. You're going to learn how these forces interact and what you as a future pilot need to understand to feel confident about how flight works. Now this is going to be a very basic explanation in order to showcase the type of content that you're going to have to master in order to become a pilot, while giving you an introduction to a very exciting topic which I personally like, which is aerodynamics. A topic like these, if I were to be explaining it to a student that is actually going through training, would take hours and hours. So a quick 10-minute video is definitely not going to cover everything, but I felt like I included the main basic concepts that are going to give you a pretty decent idea on the type of concepts that you're going to need to understand when you are doing your training. So in order to get started, we're going to talk about the four forces of flight. The first two out of the four we're going to look at are lift and weight. So lift is the upward force that pulls the airplane into the air. It's generated by the wings as air moves faster over the top surface than underneath, which we're going to talk about more into detail in the next few slides. Weight is the force of gravity pulling the airplane back down to the earth. And for a plane to take off, right, lift must overcome that weight. And as a pilot, you'll always be managing this balance to climb, descend, or maintain altitude. Moving on to the next two forces, they're going to be drag and thrust. So drag is the backwards force, or the air resistance that opposes the plane's motion through the air. It's similar to the resistance that you feel when you're like sticking out your hand out of a moving car, right? Thrust is the forward force generated by the plane's propulsion system. In the case of like airliners, it's going to be the jet. In the case of the jet engine, sorry. In the case of a small plane, it's going to be a simple piston engine that propel with a propeller. So that's going to push the aircraft through the air. For a steady flight, thrust must balance drag, or in order to accelerate, the thrust has to exceed the force of drag. In order to better understand lift, like I said before, we're going to need to look at something called Bernoulli's principle. So Bernoulli's principle states that as the speed of a fluid increases, its pressure decreases, right? So the reason why that's important is because wings are designed for the top of the wing to actually be longer than at the bottom. That makes it so that the air at the top has to speed up compared to the air at the bottom, which according to Bernoulli's principle decreases the pressure on top of the wing, and meaning that there's going to be a pressure difference between the top part of the wing and the lower part of the wing. That pressure difference is what is going to generate the lifting force of the plane. Now, this pressure difference combined with the wing shape and angle is what's going to make the heavy airplanes be able to fly pretty much, or any plane. So now we can talk a little bit more about weight. So weight is going to be the gravitational force that's pulling the airplane downward towards the center of the earth, determined by the plane's mass and gravity, and acts towards the center of gravity of the plane itself. So in order for a flight to happen, lift must be equal or exceeding weight. As a pilot, managing weight and balance is essential for stability and control during all phases of flight. So as I mentioned, right, so weight acts on the center of gravity of the plane, right? On your training, you'll look more into the characteristics of what happens as you manage the weight across the plane and you change that center of gravity, and how that's going to give you different characteristics in terms of how the plane flies and its stability. So being able to understand these concepts is very important into how you actually fly the plane. If lift is greater than weight, then the plane climbs. If weight exceeds lift, then the plane descends. If lift and weight are balanced, then the plane is going to remain stable flight. Okay, so now we can take a closer look at thrust. So thrust is going to be the forward force created by an aircraft's engines or propellers. It's going to push the air backwards to propel the plane forward, right? So it's the same idea as if you push yourself against the wall, right? You're going to go backwards. Same thing, if you push yourself against the wall with your hands behind your back, you're going to go forward, right? That's going to be Newton's third law of motion. This force is what allows the airplane to overcome drag and gain speed for takeoff and climb. So increasing thrust by adding power will increase the speed of the plane and also help generate more lift, which is essential for safe and efficient flight operations. Okay, now that we understand how thrust works, now we can talk a little bit more about drag. So drag is the aerodynamic force that resists the plane's movement through the air. It's caused by friction and pressure differences. You can think of drag like the resistance that you feel when you stick your hand out of the car window while moving. The faster you go, the more drag you're going to feel. You can also reduce drag by adjusting your hand's angle, just like pilots manage an airplane shape and configuration to minimize drag and fly efficiently. You can also kind of feel Bernoulli's principle and how lift is created. If you put your hand horizontally outside of a window, you're gonna feel, and as you start moving that angle, if you keep it kind of straight, you can kind of feel how your hand just sits there. You don't really need much force to keep it there. So it's very similar to simulating how a wing works. And as you change that angle, you can start to feel how lift increases as the angle increases, as well as drag. So those are also important concepts to understand. Okay, so now that we have a very brief understanding on how the four forces of flight act on the plane, how do pilots use these forces to control the plane in the air? So that's where the control surfaces come in. So these surfaces adjust the aerodynamic forces that we just talked about to change the plane's direction. So we're going to have the ailerons, which are going to control the roll by tilting the wings left or right. As we tilt the wings left or right, our center of lift is going to move to each side, which is going to make the plane start turning, right? The elevators are going to control pitch by moving the nose up or down. Then we're going to have the rudder, which is going to control the yaw by moving the nose of the plane left or right. So pilots use a combination of these controls to maneuver in all three dimensions, which ensures a stable flight and precise turns. Okay, so summarizing everything that we talked about, lift, weight, thrust, and drag constantly interact to determine how the airplane is moving through the air. For stable, level flight, lift balances weight and thrust balances drag. Changing these forces allows for climbs, descents, and turns. Bernoulli's principle and the use of control surfaces make control safe flight possible. And as a pilot, understanding these principles is crucial for making good decisions and flying safely. And also having a good understanding of these concepts is going to make your flight training a lot easier, because then you'll be able to understand what's actually going on in the plane. Thank you very much for joining me on this module on the four forces of flight. If you have any questions as you continue your aviation journey, please feel free to reach out to me at info@futurewings.space, and I hope I gave you a brief understanding of the aerodynamics and how a plane flies. Thank you very much.